It is now. All right, so we're going to start with this page and talk about what the x and y intercepts are. So the x-intercept is where the line crosses the x-axis. So it's where the line crosses the x-axis, which makes sense. It has x in the name. It makes sense. So if you're thinking football, intercept always makes me think of football, interceptions. It's where the guy, like, he's going this way, the ball's going this way, and they meet, and he catches it. It's kind of the same thing. It's where the x-axis and the line meet. So the y-intercept is where the line crosses the y-axis. So same thing, except it's the y-axis. So those are really easy vocabulary words. They basically say what they mean. And then we're going to label stuff on the picture. Okay, so here we go. So we're going to label some things on some actual examples. So down here it says find the x and y intercept for each line. I'm going to use some color just so this shows up. You can just use your pencils. It's totally fine. So I'm going to start with the x-axis first. So here's the x-axis. So I'm looking for where the line crosses the x-axis. Oh, there it is. And it's right there at -1. So I would say that the x-intercept, I'm going to abbreviate it, is at -1. So I abbreviated x-intercept a little bit, but it's right here at -1. Okay? I'm going to color code this just so it'll... So then I'm going to look for the y-intercept. So I'm going to look at the y-axis, which goes up and down. I'm going to go, okay, where does it cross the y-axis? Can you guys tell me? Where does it cross the y-axis?
-2.
At -2. So that point right there. So I'm going to say that the y-intercept is -2. So that's the main idea for today. X-intercept is where it crosses the x-axis. Y-intercept is where it crosses the y-axis. Does that make sense so far? Okay.
The colors is almost up.
I know. It's almost the end of the year, and all of the highlighters are running out. All right, so let's take a look at number 3.
No, the color is different.
All right, so the x-intercept is where it crosses the x-axis. So I'm going to go on the x-axis back and forth and look and find the point where it crosses. It crosses right here at -2. So I'm going to say the x-intercept is at -2. And then I'm going to go up on the y-axis and find out where it crosses there and say my y-intercept is, where does it cross the y-axis? Can you guys tell me? At 4. Good. You can talk. It's okay. We're just recording the lesson, but you can interact and I'll repeat it into the microphone.
Gracie, it's 4.
Okay. All right. So let's go ahead and look at number 4. So what is the x-intercept? Go ahead and tell me. 1. Good job. Right here at 1. So I'm going to write down that the x-intercept is at 1. And where is the y-intercept?
-4.
-4 down here. So we can say the y-intercept is at -4. Okay. This part is really easy. I agree. So let's look at number 5. So where is my x-intercept? So we look at the x-axis. Where is it crossing? At 3. So I'm going to say the x-intercept is 3. Where is the y-intercept? I think it's right up here at 3. Sometimes it will be something like 2.5. I tried to make these easy so that they always cross on integers, but sometimes they will come out as fractions or decimals. Okay, so that's the main idea of what x-intercepts and y-intercepts are. Now, when we start looking at graphs that go with a story problem, we can do a little bit more with this. And that's what's on the other page. So let me get this all set up. We've got a couple of examples where they didn't really give us the story, they just gave us the graph. And what we're going to do is we're going to interpret some parts of the graph based on what it says on the labels. So the smaller graph at the top says pie eating contest. So I don't know if you guys have ever watched a pie eating contest. It's really gross. People eat and eat and eat and eat until they get sick. And they try to see who can eat the most pies. It's interesting. And so if we look over here on the left side, it says cream pies remaining. So we know that that's our dependent variable because it's on the y-axis. This is how many cream pies are remaining. And then on the x-axis, it has the time passed in minutes. So this is 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes, and goes on. So you can tell with the slope going down, it's a negative slope, that they're eating the pies and the pies are disappearing. Okay, so now we have an idea of what's happening in this. I always look at the graph and kind of look at the title and look at the labels to try to figure out what's happening before I read the questions, because for me, that just means that I'll understand the questions a little bit better before I get started. So it starts on number 1. It says, what is the y-intercept? So we're going to look, where is this line crossing the y-axis? At 10. So this right here is my y-intercept. So I'm going to say that it's at 10. And then it says, what does it represent? So this is sort of the starting point. It's on the y-axis at 10. What does 10 tell us? Yes. Yeah, there's 10 pies. So if we look at where that corresponds to time, that would be when the time was 0. So nobody had eaten any pies yet, and there were 10. So we could word that by saying that we started with 10 pies. That's what it means. So we're starting with 10 pies. Does that all make sense to you guys? Because that's at time 0. That's my y-intercept. The y-intercept is usually a starting point for your story problems. It's usually where everything gets started. Okay, so on number 2, it says, what is the x-intercept? So let's go down here to the x-axis and see where that's crossing. It's crossing down here at 8. So that's my x-intercept, and I'm going to write that over here. And so it's crossing at 8. So what does that 8 represent?
It means time.
It is time. It's 8 minutes. And what happens at 8 minutes? When it hits the x-axis, what happened to all the pies?
It's over.
It's over. The pies are gone. And so yeah, it means it took 8 minutes to eat all the pies. It actually says cream pies over here. So these are the cream pies. So chances are there were cream pies and fruit pies and maybe pecan pies.
I cannot eat that fast. I need to take time.
Well, this is more than one person too, and they only recorded the cream pies. When these contests, they eat more than that, and there's always rules about what counts as eating the whole pie. Like, do you have to eat the crust? Do you just have to eat the filling? And each competition has its own rules. It's really disgusting. Something they do at like state fairs.
Personally, I don't need a whole pie.
I don't need a whole pie either.
A piece.
Yeah, I know. I know, right?
Eating contests are really,
they're just
gluttonous.
They're gross.
What that word glutton means? It means you just
eat and eat and eat until you.
It's really gross.
It is gross. Okay.
I'm really excited.
So This is where this is going to tie into what we were doing the last 2 weeks. What is the rate of change? In other words, the slope. It's the same thing. And what does it represent? So we're going to find the slope. So I can start with the y-intercept if I want. And the x-intercept. Those are points that we know if we want to use that. Is the slope positive or negative? It's going down, so it's negative. So I'm going to put a negative down just so I remember that. And then I know that this is going to go down 10 and over 8, right? So down 10, so minus 10 and over 8. And then we've got to reduce that. So we'll divide by 2. And we get negative 5/4. So if we think about what these numbers were, the negative 10 represented the pies that were getting eaten. And this was the time in minutes. So they ate 10 pies in 8 minutes. Or if you look, there's actually a point in here in the middle where it crosses the grid. They ate 5 pies in 4 minutes. And something else that we can do with this that works with story problems that we don't normally do is we could actually divide these to change them into a decimal. Remember changing fractions to decimals earlier this year? So I'm going to take my calculator up here.
It's been a while.
Yeah, it's been a while. I'm going to take negative 5 and just divide by 4. We're going to do it the easy way with the calculator. So I just use my divide key. Okay? Divide it, and we get negative 1.25. So that's another way to write the slope. It's negative 1.25. And that's how many, so it's negative 1.25. So that's the slope or the rate of change. We could circle the fraction or the decimal. The decimal is useful because it gives us what we call a unit rate, which you don't need to know right now, but we've talked about it before. What it means is that's how many pies they eat per minute. So it's negative 1.25 pies per minute. So every minute they're eating a pie and a quarter of a pie. A cream pie. They're eating other kinds of pies too. This is just tracking the cream pies. It does kind of make you hungry, huh? So this is what it means. It's giving us that unit rate. It's negative, or you could also call it rate of change. They're eating 1.25 pies per minute. 1.25 pies per minute is disappearing, which is why that negative is there. They're going away. They're being taken away by the people eating pies. All right, so let's come down here to this big graph. And this got cut off a little bit when I was printing it, but we can still read it. This is John's savings account balance for the year. So this is a savings account at the bank. He's saving money. So let's look at what's down here on the x-axis. We have months. So this is tracking a whole year. It's got 12 months. Up this side, it's got the number of dollars in the savings account. And so they're tracking his money in his savings account for a whole year. Okay? So we've kind of got the idea of what's happening. This is John's savings account. All right, so the first question says, what is the y-intercept? So where does it go through the y-axis? So this is the y-axis right here. Where does it hit? At 300. So that is my y-intercept. So we're going to say that the y-intercept is 300. And we said that the y-intercept is often a starting point. So this means at the beginning of the year, before any months had passed, how much money was in his account? How much money did he start with? 300. So he started with $300 in the savings account.
That's a pretty good start.
That is a pretty good start. I don't even have a savings account anymore. It's kind of sad. I used to. All right, now this is a tricky one. It says, what is the x-intercept? So is it crossing the x-axis over here at all? No, but I'm going to show you something. They're not giving us the whole graph. They're only showing us 1 year. So we could take the x-axis and go backwards a little bit and try to keep the spacing, -1, -2, -3, and we could kind of figure out if we extended this line where it was going to hit the x-axis. So we couldn't see it, but you could kind of extend it. So it looks like it's actually hitting at -3. So that's my x-intercept. So down here I'm going to write -3. And then it says, what does it mean? So if this is a year, 1 month, 2 months, 3 months, 4 months, there's 12 months passing, then we're still doing months, but we're going backwards. So that means if we go back 3 months, that's probably when he started the savings account and hadn't put any money in it yet. So we can interpret it that way. Sometimes they would just say there is no x-intercept. Maybe he started with $300 and there wasn't 3 months ago. We really don't have enough information to know. But we could say that it possibly means he started the account
He probably
3 months.
His saving account probably like $10.
Right. So it's possible that he started it over here, but this may not have existed. He may have had $300 he got for his birthday or Christmas. He may have started the account here, and there may not be an x-intercept, so we really don't know. So you might want to put a little question mark next to that. And I won't give you one of those on the assignment yet, but I just wanted you to be thinking about sometimes these problems are a little bit interesting, because if you don't actually have the story problem that goes with it, this is open to interpretation a little bit. So what we did is we were assuming that this line extended back 3 months. And if we make that assumption, then that's when he didn't have any money in the account. But we don't know that for sure. So that's just what we're going to say for right now. All right, and it says, what is the slope or rate of change, and what does it mean? So let's go up to our line here. And what we want to do is pick 2 points on the line, which is going to be easy because... Oh, I'm sorry. So what we're doing is we're trying to figure out the slope. So it looks like there's points all the way across. It hits here, it hits here, it hits here, it hits here, it hits here. So what we need to do, though, is think about the scale and how they numbered things. So I'm just going to pick a couple of points. Let's just start down here at the 300. So it's going up 1 box, and it's going over 1 box. But is it really going up 1 and over 1 the way that this is numbered? So how is the y-axis numbered? It's going 100, 200, 300, 400. So when I go up 1 box, how much am I actually going up? $100. So I'm going up $100 and over 1 month. Up $100 over 1 month. Up $100 and over 1 month. Did you have a question? No. Okay, so on my slope, it's a positive slope, and I'm actually going up $100 for every 1 month. And so my slope, you could just call it 100.
It could be $1,000 if that's by the time you get to.
Yeah, he's got quite a bit in his account. And so what does it mean? Is it means he's depositing or putting in $100 per month.
Good for him.
I know, good for him. He's putting away $100 every single month. And so this is the kinds of things that they expect you guys to get from graphs. We actually talked a little bit about points on the graphs when you guys were in 6th grade. That's what we're looking for.